So the tea coffee guy said we had tea, coffee, and danishes for free.
Sorry, what?
The tea coffee guy said he's giving complimentary tea, coffee, danishes for us.
Today?
Yeah,
When?
he'll drop it like 20 minutes, and we can, if we, but we don't have time for break, right?
No. Hello. Good morning. No, it's never the evening. It's always morning on the IC. Thanks for coming. As you can see, we're a bit fewer than yesterday. Some people had crazy night in Dublin, as expected. The schedule is going to change a lot because I've had a lot of people who want to speak. So this morning we're going to start with 2 talks, and then we'll do lighting talks. The 2 talks first is going to be Martin and then Mark. For the lighting talks, some of you said that they wanted to have a lighting talks, but they've not sent me a PDF, which means they won't do a lighting talk. So you have half an hour to send that. And as for lighting talks, it's going to be 10 minutes, and it's going to be timed, because we don't have enough time. Thank you very much.
Is there a schedule for the lighting talks?
No. Basically, the schedule is this.
Do we use these? Yeah. Which one is this one? Let's try. Let me double check our Kika. Kika works.
Hello. None of them work. You need to use that one.
Clicker is there for you. Is the live stream working?
You think so?
I'll just double check before that.
Yeah. It should be, right? It's in red.
Do you trust that even?
Yes, yes, we do trust.
Okay. Okay.
Check on your phone.
All right, good morning, everyone. I'm going to talk a little bit about the tool chain that I've been developing the last quite a few years now. It's a MinGW targeting tool chain that is using the same setup as GCC and the other tools with a freely distributable, properly licensed open source SDK and everything. And most of the LLVM components, like the LLVM project provides a number of components that you can use as drop-in replacements. Thank you. In an existing toolchain. So if you have, for example, regular setup, you could use Clang instead of GCC. Or if you wanted faster link at times, you could compile with GCC, but link with LLD instead of the other ones, and so on. But what LLVM MinGW is a full toolchain where you have swapped out all of the components for the other ones from LLVM instead. And why am I doing this? So originally, many years ago, VLC wanted a toolchain so they could do VLC for Windows Phone. So I wanted to target Windows on ARM and also at some point ARM64. Windows Phone is not so much of a thing anymore, but Windows on ARM64 is still a thing. So originally I only wanted to target these new fancy architectures, but I ended up making a full toolchain universal for all 4 of these architectures with a bunch of modern features like PDB, debug support, address sanitizer, also security features like control flow guard, and so on. And it turns out the LLVM codebase is very easy to work with. So there are bugs and things missing, but it's usually quite easy to fix these things. So within this toolchain, I follow the principle of doing things upstream first, or almost upstream only. So I'm not taking the shortcuts of having a bunch of patches that I haven't gotten through review, but instead the aim is that whatever I do it upstream, because my intent wasn't, I didn't set out to make a toolchain. I didn't want to be a toolchain distributor. I just wanted to fix these things upstream, but then it turns out that actually assembling and setting up the whole tool chain isn't quite trivial in the end. So I needed like a reference example of how to do this. So as I said, this grew out of, there was just a Docker image for a VLC build bot with a bunch of patches on top. I grew out of that in 2016, 2017. At the end of 2017, I figured out that we can't just have this as VLC build bot, whatever, but you need to set a name for the project and so on. And by the end of 2017, we had support for targeting ARM64 on Windows, which didn't really exist yet. By early 2018, we could build unpatched VLC for Windows on ARM64. And pretty much started out mostly focused on cross-compiling things. But these days, people also want to develop on Windows in various settings. So last times I've talked about this, the general sentiment has been that this is quite new, immature, things will break, but at this point I would say it's fairly mature actually. So as I said, my point wasn't to do this just for my own setting and my own distribution. There's the other project that you might know of, MSys2, and some in this audience have said that I don't think MSys2 is relevant anymore, but MSys2 is like a small Cygwin-based environment for running Unix emulation of things, and you'd need this if you want to compile things with automake, autoconf, and so on. But the Unix emulation is not really the main point of MSys. They are mainly like a Linux distribution of, or Windows distribution of a bunch of open source packages that may or may not need the Unix emulation environment. At the moment, they have something like 2,700 packages, and the, oh, come on. Okay. Yeah, so originally MSys2 consisted of 3 environments. These are like different sysroots that are glued together. So you have MSys for the packages that are built with some sort of Unix emulation. And then you had 32 and 64-bit environments with the traditional GCC-based setup. But in the last few years, they have added a few more environments. They have added one UCRT64, which is the traditional GCC-based setup, but everything compiled to run on the new C runtime, the UCRT, which is much newer, much less hacky than the old one. Then they also added one called Clang64, which is pretty much the same as LLVM MinGW. That is, they use Clang LLD, all the LLVM libraries as the system compiler for this environment. And they have essentially all of the packages building this. There's some of them that don't build, but the vast majority of them do. They have the same for 32-bit, but that's not really that interesting anymore. And they also have tried starting out doing this for ARM64. So last time I gave a talk about this on VDD 2019, and what's happened since then? At that talk, I mentioned that I'm looking into making LLDB work. It does work, has been shipping since. Once I shipped LLDB, people also started asking that they want to integrate this with their IDEs, and to do that, it's better integrated if it supports Python, if it's built with Python enabled. Well, building Python for MinGW is messy since it doesn't really support, it only supports MSVC. So, but the MSys team actually maintains a fork of Python with MinGW support, contributed by Long Nguyen, integration into my build, and also had another contributor called Alvin Wong, who contributed quite a lot of fixes on LLDB, making it actually work well for him and others. Other small nitty-gritty details since then, LLVM used to produce backslashes in all the output everywhere. So in some cases it had horrible hacks where I piped the STD output from Clang and translated the slashes to forward slashes for the cases where it was needed. So this is fixed upstream now. You can whenever you build LLVM, you can configure what's your preferred / direction. I have added support for std file system, the C++ 17 API in libc++. Recently added support for doing standard input-output in Unicode mode in libc++. Upstreamed the resource compiler, which used to be an ugly wrapper as well. Implemented SEH, unwind information generation for ARMv7. Also for, not so much for MinGW, but more about LLVM in general. This spring we looked into some ARM64 extensions, which you couldn't really toggle as you were supposed to from assembly. So I fixed that, and that's released on Tuesday actually. And I've spent quite a lot of time on testing, which I'll talk a bit more in a little moment. Another fairly interesting optimization that I did is that when you're compiling for Windows with the SEH unwind information, whenever you're compiling, even if you're compiling C code or C++ with F no exceptions, it does generate unwind information, and this can be larger than you want to, at least. And the initial support for this was contributed by Qualcomm, I think, in LLVM many years ago, but it was fairly naive, so it produced quite a lot of data. So for a 6.5 megabyte DLL, it had over 400 kilobytes of just metadata of how do you unwind out of this function. And in most of the time, you don't really need this, but it's, you know, it's still there, enabled by default, and fairly big. So a couple of years ago, I took some time to optimize this. The SEH unwind information format for ARM64 is fairly clever. You can encode it extremely compactly if you just generate code in the right way, and if you just make the unwind information emitter actually be aware of how you can encode things more compactly. So it shrunk to over less than half of that, and compared to what you generate for x86 64, it's smaller and more compact. And you can even see this like on the large scale. The full zip of VLC shrank by 600 kilobytes. Another problem that we run into recently is that when you build LLVM, it's big. It's quite a lot. So by default, the default setting for building it is that you have all the common components, all the common libraries linked into every binary statically. And that means you have like a 100 megabyte Clang exe, then you have a 70 megabyte LLD exe, and then you have all the other tools, 50 megabytes each, and so on. And that's quite wasteful. So you can instead link all the shared code into one common DLL, liblLVM and libclang CPP, and that cut down the size of the distribution to much less than half. But then you have the issue that within this common DLL, we're exporting all the symbols, and the symbols are quite a few. You can only export up to 65,000 symbols in this, and I was getting uncomfortably close to this, like having 64,000 out of 65,535. MSys were also running into this quite a lot. I only build the targets I really care about, ARM, AR64, and x86, but they used to build everyone, but for each release they had to drop like a couple targets that they found least possible that somebody cared about. They dropped, you know, MIPS and PowerPC and this and that, but they were also getting quite close. So the way we fixed this was by emulating the ELF hidden visibility thing. So on a source level, you can tag individual symbols saying that this one shouldn't be visible outside of my shared object in ELF speak, or you can compile an entire object file with fVisibility hidden, meaning that everything is marked as hidden unless you told otherwise. So I invented a way of doing this in the COF object format and had to add linker support for this. And since you can use Clang with both LLD and GNU LD, I need to add this linker support to both of them, which I did last year. And if you then take these attributes into use, I got from almost hitting the limit down to 35,000 symbols, and I have quite a lot of headroom still to go. Another thing that's happened is release building automation, making it much less annoying to build a release. So LLVM does 2 major releases per year. For each major release, there's 3 or 4 release candidates before, and then there's more point releases, maybe 4, 5, 6 point releases afterwards. And I used to make a release of the first release candidate, so people get something to try out, and then the first stable release. But since I have set up automation of building this, I can now do this for every single point release and all of the RCs, which is essentially every other week. I'm going to show a small example of how things are, how do you set up a cross-compiling toolchain, which we'll see a bit more about later in the presentation. So if we really, really simplify things a lot, if you're on Linux, you use the system compiler, USR bin GCC, G++, and we compile, let's pretend that all of Clang is one CPP file. It's not, it's like many, many thousands, but let's pretend it's one CPP file. You compile that to a native binary, Linux binary, in my toolchain directory. I run this, and with my Clang binary, I can tell it what target do I generate code for. I compile my hello.c, and I get a foreign binary running, which I could execute on Windows. So this is the really trivial way of showing it. If you want to pretend it's slightly more like reality, I build more than one tool. I build Clang and I build a DLL tool. I use these. I don't only compile things for the Linux environment in order to set up the cross compiler. I also need to build some things for the target. So for example, I produce an import file for kernel32.dll from a dev file, just a list of what the symbols are. In practice, there's like hundreds of those. And then I compile some of the CRT process startup files. There's also a bunch of other glue code and things. But to get the idea, first you build, using the system compiler, you build the cross compiler. With the cross compiler, we build some things for the target. And when actually building my toolchain, these things for building things for the target, I do this for all 4 architectures in a loop. And then we're done, we actually have the toolchain, you can use it to cross-compile things. Then if I am on Linux and I want to build a toolchain that will run on Windows, I do kind of the same. So with the toolchain that I did in the last slide, I build clang.cpp that we pretend is still just one CPP file. With the cross-compiler, I get a new binary that runs on Windows. But in this case, we can't really mirror the whole setup from the previous slide, since the compiler that I just built is as a Windows executable. I can't run it on my Linux system. So instead, we just copy over the files from the toolchain we built initially and package it along with the compiler that we built for Windows. And then we can zip it up. And then we have a full toolchain that runs on another system, any architecture of your choice, and produce this without ever actually running Windows at any point. So how do you test these things? The issue is that LLVM is evolving at an absolutely insane pace. There's like 100 to 150 commits per day. Between every major release, twice a year, there's like 17,000 commits. And every single one of these can break things. They can break things quite subtly. You won't notice. Things, just doesn't do the right thing. Especially within the code generation, when there's a dozen or many dozens of passes doing one transformation, then another transformation, then looking for patterns and so on. If one early pass does something slightly differently, then a later pass can, start doing things that it didn't do before, and then you could have like silent bugs being in code for in the code base for many years, and then suddenly there's one completely innocent change, and then you are starting to miscompile things. So how do you avoid the regressions? You could just stick to stable releases, hope that somebody else has tested this, hope that somebody else has fixed all the bugs, and don't care about it. But if you are doing things on a major environment where you know that many others are doing the same, then yeah, sure, you could stick to the stable releases and just hope that somebody's fixed it. But if you're doing things in a slightly more niche case, then you can be quite sure that nobody has tested exactly this that you're doing. So it's safest and best to continuously test what's happening in the latest Git. So I don't build and test things so much what others care about. I build and test the things that I care about. And if you have tested or set up fixed building some project, then you want to continue testing that continuously, because otherwise things will break. And if you tested that this worked 3 years ago and I have no idea if it works since, then debugging things is quite painful. So there's also the opposite example. The Chromium team within Google, they don't use stable releases at all. They update their compiler to latest Git every 4 or 6 weeks or something, and they just, as long as you know that you have complete enough test cases for what you're shipping, they don't really care about if the compiler is broken in this or that way. If their code compiles, runs fine with all their tests, that's good enough for them. So how is LLVM itself tested? It's mainly tested with a lot of many and very narrow unit tests. So if you do any bug fix, any change, if you're changing the behavior of anything, your patch needs to have a modification to a test. You add a test, you tweak a test. If there's a functional change, it should be visible in the tests. So most of the tests are just a bunch of small shell commands together with a small input file. So it could be like a 10-line assembly input file that it assembles and then checks that the output, it doesn't check the whole output, it just checks for the small details that we're interested in this case. Or it could be like a small function, compile and check that this particular part of the prologue, it has emitted these or those instructions or so on. So, and the good thing here is that it only generates code, it doesn't ever try to execute the code anywhere, which means that if you are IBM, you're testing the latest LLVM on PowerPC somewhere, if I have added a test case for AH64 and they have actually built Clang with AH64 enabled, when they run the tests, they also will test my tests. And they will see if they break whatever code I have added there. So this adds fairly good, regression coverage in that sense. But as I said, you never execute things, so you don't really know if it actually works in the end. So they have a big test suite of lots of different things. It can be used for benchmarking or whatever. I haven't really looked into it since it doesn't support Windows, and I haven't taken the time to fix it to do that yet. But I'm not sure how much actual coverage of real-world cases you would get from running this test suite. Maybe it's good, maybe it's not. So instead, I test my own things. So if you're taking a random version of Git, of LLVM from Git, what could break? Well, essentially anything, but I tried to classify it into a couple of different scenarios. So the first scenario that can break is that I used to be able to compile it. Now I can't compile LLVM anymore. It can be that you're using like a fringe compiler, fringe environment. And that's fairly straightforward to fix. It could be that last week I was able to compile VLC. This week I can't, because Clang says that your code has an error. And that's not a bug, usually. It could be. But in most cases, it's just that your code is, slightly imperfect, so fix your code. Then we have the really tricky case, but my code builds, but it no longer does what it's supposed to. So if your code has undefined behavior, then it is usually your own code's fault, and you should go fix it get rid of the undefined behavior. But if your code doesn't have undefined behavior and it no longer does what it's supposed to, it's quite possible that your code has or that you have found an optimizer or code generation bug. And the sooner you catch this, the less painful it is to deal with. So the first step is usually to bisect which commit of the 100 to 150 commits per day that triggered this. If you do it within 1 day, then you have just, a couple hundred commits to bisect. If you realize that, yeah, this broke sometime in the last 6 months, then you have 17,000 commits to bisect through. And you can catch these quite easily if you have tests like FFmpeg's fate tests that are just purely computational. You can run these in Wine on Unix, anywhere. It doesn't really care about what Windows is. You just compile your binary in this format and see that if you run it, does it produce the right output. There's also, yes, Anton?
Could you give an example of code that doesn't have UB?
Well, that's a good question. Well, at least, yeah, so Anton said that could I give an example of a code that doesn't have UB? Yeah, well, I guess all code bases have more or less at least. But, I mean, if you compile it with UB-SAN and it doesn't flag anything for this case, then I would start looking at the compiler, not at your code. There's also the class of issues where you're actually using Windows APIs and you're doing this incorrectly. And that really does require you to run things on Windows, which, like, I'm not a Windows guy. I run other operating systems, mainly. So I don't really like running things on Windows. So I test as much of this as I possibly can on non-Windows, because it's so much easier to automate and set up and run and so on. But sometimes you do actually need to test things on Windows. These things break much more rarely, and usually not so much by accident, but actually, you have a functional change touching this API, and then you need to actually, when you need to test things, mainly. So for the annoying class of bugs, of code generation bugs, if you build your build of LLVM with asserts enabled, luckily you can catch most of these like at compile time. So if you build your LLVM in the regular mode with assertion disabled, then pretty much if you hit these bugs, anything can happen. But if you build it with assertions enabled, then LLVM will crash and tell you right away when you're compiling that I'm not sure what I'm supposed to do here. And if you have a case where you trigger this situation, it's so much easier to figure out and pinpoint where's the actual bug, because you can reduce it so much easier. And you don't need to argue about it, that is there a bug, is the bug in your code, is it in my code. This fairly valid looking C code, it used to compile yesterday, now it crashes the compiler, then the bug is usually in the compiler. And we try to push a revert commit in LLVM as soon as you find this, since there's many people touching and using the same code base. If you have found a regression, please, take it away so you don't hide other issues with it. When you build Clang with the asserts enabled, it's slower. It's something like, depending on 20–30%, maybe 50% sometimes, slower than a regular build of it. But if you're not using a stable release of Clang, I would highly suggest that you are using a version built with assertions enabled, because it will, you will find these things much easier. So if you hit the case where you actually trigger an assert, you want to report it, you can. The steps is usually you start out by, when you compile things, it's you start out with something that depends on a bunch of headers and this and that and things in your environment. So start out with taking out the -c, -o arguments from your compile line and add -e instead, so you pre-process it. So you pull out all the things from the headers, and you produce one standalone C file which can give it to any compiler, any instance of Clang anywhere, and trigger these issues. And then there's a fantastic tool called C-reduce, which takes one of these files and you give it a shell script with an interestingness test. So essentially, it just tries compiling this C file and see that, do we still trigger this assert. And this tool will then try to automatically reduce the input C file, taking out this function. Is this needed? Do you still trigger the assert, and so on? And does this iteratively until you have the minimal C file that triggers the assert and you can't take anything away while maintaining this property. So usually, like, when this happens, you start out with a preprocessed file of many 100 kilobytes, sometimes many megabytes even, and you run this, you go for a coffee, go for lunch, and you come back to a 10-line small reproducer, just, usually a loop or two or something that triggers the assert. And if you give this to the guy who caused the breakage, it's much easier to work on it for him or yourself if you want to as well. Then there's also, of course, the class that, yeah, my code compiles, and it doesn't trigger any asserts, and it still doesn't do what it's supposed to. So then you report usually the full case. They have actually added an LLVM-specific tool called Alive2 that takes, if you pinpoint which exact optimization or transformation step caused this, it can test that this code and test all the possible combinations of inputs in this code and see that, like, for these specific inputs, your transformation is not valid because before the optimization pass, it did one thing, now it does something else for, like, this specific valid input. And if, in most cases of this, just, give the full case to the one that caused the breakage and say, could you please have a look? In some cases, I've even pointed people to, this is how you clone FFmpeg, this is how you download the test suite, run this test, and you will see that it will break. It didn't use to, can you please fix? Luckily, this is fairly rare, though. So to do this testing, you need to compile LLVM, and this takes a long time, a really, really long time. It's like on the same order of magnitude as building all of VLC from scratch, including all the dependencies, all of Qt, all of everything that's involved. It takes a long time. And then when you build this to test your toolchain, you need to also build all the projects that you want to test, and this also takes a lot of time. And there's always somebody asking that, well, can't you cache things? And can you use Ccache to speed up your testing? And in most cases, no, you can't really. It doesn't really help anything. So if you just fetch LLVM and rebuild in the same build directory as before, then you don't need caching because it will rebuild whatever objects you need and nothing else. If you are running like in a new environment, you wipe the directory from before, or like start up a new VM and build there, then caching, yeah, it could help some things, but if you do this like once a day, there's usually so many commits during that one day that 80% of your source files will need to be rebuilt anyway, so your cache doesn't really gain you anything anyway. The code just changes so much every day. When you're actually developing interactively, though, having Ccache is actually quite helpful because otherwise, if you spend like 2 hours compiling LLVM to do something, and then you accidentally, or you change branch to something else and back, and then you realize, oh shit, now I need to recompile 2 hours before I can do anything again. So in those cases, Ccache is very helpful. Then when you actually have the build compiler and you want to test all these building FFmpeg, building VLC or whatever, you don't want to use any caching. If I cache things and I don't rebuild the files with my new compiler, then I don't gain anything from testing. I want to make sure that when I build things, when I build everything with a new compiler, I want to see that does this work, does it trigger asserts, does it actually work, and so on. So caching doesn't really help anything there either. So to test this, I have had an old desktop computer at my office. It's 12 years old, it's really nothing fancy. And I have a night to build job while I'm asleep that takes the latest LLVM, latest MinGW, latest everything, compiles it, runs a small set of tests to see that it's not entirely broken. And if it's entirely broken, we just discard it. If it's not entirely broken, then I install it as the latest nightly in my machine. Building this can take up to 2 hours, but I usually have some tricks to avoid that. But that's too detailed. Then when I have the latest nightly version of this, I build the latest VLC. I build the latest VLC, I don't build a known good snapshot because I don't have time to test both, and testing the latest GitHub VLCs gives much more valuable information than testing an old snapshot. This can take up to 2.5 hours, and of course I would want to test everything building this for all 4 architectures, but I don't want to spend 10 hours on this. So instead, for every nightly build, I pick one of the 4 architectures, round robin, and build one. So if there's some architecture independent breakage somewhere, I will know it by the next day. If there's some architecture specific breakage, I will know it within 4 days and have, still not that many commits to bisect through. Since VLC is a GUI application, I don't run any tests for this or so on. I just compile it, and that's quite enough code coverage for testing for this. I store the build packages, so if I want to go back and, if I try and see that it actually doesn't work in my configuration, but it did work half a year ago, then I can test the pre-built packages in between and pinpoint the day where things actually broke and look into it later. Then I build FFmpeg and run the Fate test suite. This I do build for all 4 architectures every single day. Run the tests in Wine on Linux, since I really don't want to run Windows anywhere. I test the x86 architectures on the same local machine, 12-year-old desktop, nothing fancy. And I run the ARMv7 and AR64 tests on a small dev board, building on x86 and then running the tests over SSH on Linux in Wine on this dev board. This in total takes a bit under 3 hours. And then this catches quite a lot of bugs, actually. Then I also build and run tests for a bunch of other projects, x264 David, OpenH264, libvpx, and AOM, and so on. The others don't usually catch as many bugs. FFmpeg catches lots of bugs, though. So with essentially 0 investment in hardware, I have a fairly confident test setup catching quite a lot of bugs for the cases that I do care about. And I tried looking into things that how often do things actually break in the end. I hadn't looked at this statistically before. I just had some rough guesses in my head. So since the start of April until a couple of days ago, it progressed by 18,000 commits. And building LLVM from scratch with the MinGW stuff broke within this time 11 times. Once was because of a broken header installed in MinGW. The rest of the cases where LLVM itself wasn't possible to compile in my setting. There's been 9 times where there's been code generation bugs that has triggered asserts that are straightforward to report. Or actually, the number 9 is old, because on Friday, when I was traveling here, I looked at my phone and saw that, oh, today's night they actually had regressions, and this triggered asserts. There's been 2 times in this time period where compilation has worked just fine, but some tests produced the wrong thing. Once was in the VMA decoder in FFmpeg. I told the guy that, could you please just clone FFmpeg, try to build this and see why you're breaking this. And in one case, this has been a case where there was no assert triggered, just when compiling, the compiler itself crashed outright once. And then there's also the case where FFmpeg's Fate, since I run the latest version of this, of course, from Git, Fate itself, FFmpeg was broken. That was 8 times, or 8 days within this. And every day when FFmpeg's Fate is broken upstream, that does annoy me, since it shows up in my tests and I need to look at it. It can easily hide actual bugs. So that's why I annoy people quite a lot to please fix or revert or whatever. So the conclusion is that if you take a random snapshot of LLVM Git, 87% of the time it's good enough for my use cases. Then sometimes you do need some manual testing. So I used to do, when I do a release twice a year, or also release candidates, I actually fire up a Windows virtual machine and try to test things, run some small set of smoke tests. Running a small test case with address sanitizer, intentionally triggering a write out of bounds and see that does address sanitizer catch this. Test LLDB, run a small crash, check that can I get the backtrace, does both debug info formats work, can I set a breakpoint, can I stop at it, can I continue and so on. And many of these things are probably tested by Google in some of their setups, but they are not, they test it in other configurations. I want to test exactly the MinGW configuration that I'm shipping. And the conclusion is that manual testing is boring. You often just defer it. I tested it once, and then half a year later, I should test this, but do I take the time to do it? You know what happens. So instead, I've invested more in more testing. So at some point, the libc++ project took quite hard stance and said that they want to have everything tested in a pre-commit CI configuration. Every single patch that you post for review runs through CI, and if your platform is not in there, it's not on the list of supported platforms. So they took a real hard stance. They had a list of platforms that they do support, and everything that isn't in CI was removed from the list, more or less. So some people at Google have had regular testing of libc++ on Windows, but the Billbot had gone away and been away for a couple of years or so, and the bit rot was quite severe. There were like hundreds of tests failing and so on. But someone at Google had also set up some Windows VMs that were used for other parts of LLVM testing in other parts of CI. So I hooked this up to use their machines for the libc++ testing. Had to clean through quite a lot of tests to either fix the test, fix the bug, or explain that this is we know that this is failing, and we know that it's failing because of this and that, instead of just we don't know. And on the same machines, we also added a release of LLVM MinGW, so we could test things in the MinGW setup there. So it's not that just Windows is an officially supported platform in libc++ these days. The MinGW configuration itself is also officially supported. And this is the libc++ test suite has actually found a handful of bugs also in MinGW CRT and other places. So it's quite useful extra coverage. So going further, I also looked at GitHub Actions for running and building and testing things. The thing is that they provide free CI runners. The runners are slow, but they're free. Each job is limited to 6 hours, but you can have a long pipeline consisting of many of these stages. And the really big thing is that they provide macOS and Windows runners as well. So this means that you can automate and run things on Windows that somebody else maintains having it running. So first, I set up a nightly build trying to mirror what I had locally, and building on Linux, building the cross-compiler. Then another step, using the cross-compiler to compile the tool chain for running on Windows. And then we actually have the final Windows-hosted tool chain. We can finally run the small set of smoke tests, testing LLDB and sanitizers on Windows, automated within this, so I don't need to test it manually in the releases anymore. Except that for Windows on ARM, well, there's nothing such on GitHub Actions, so that I do need to test semi-occasionally. So the full setup that I have on GitHub Actions these days is that I build the tool chains on Linux, on macOS, and I also test building them in MSys just because I don't ship that anywhere, but just I want to know if things break or not. I cross-build the tool chains for all the 4 target architectures every day. I build one tool chain with assertions enabled, and I use this to test building FFmpeg. I just build, don't really run anything with it, but this catches some of the cases. I have all the same setup locally, but this also mirrors it publicly on GitHub so others can see what's happening, and it's much easier to point people to the failures. I wanted to use the assertions enabled toolchain to build the other steps, build the second stage toolchain, but it was too slow. You have the 6-hour limit, and sometimes, most often it did finish in time, but it hit the limit way too often. And then we have things completed. We also run the sanitizer test suite, which was cleaned up so it runs in the MinGW setup, and run OpenMP tests and so on. So we have actually a fair amount of actual Windows runtime tests in this schedule build these days as well. So this is what the pipeline looks like these days. We start out with one job to prepare, checking what's the latest version from Git from all of these projects, and set up one job running on Linux, building this, one job on Linux, building with assertions. The first one running 3 hours, the second one slightly less than 3 hours, building things on macOS as universal binaries. Took almost 5 hours this time. Then building things on MSys. Then with the Linux built toolchain, we cross-compile the whole toolchain, taking 4 hours, 3 hours, something. Sometimes this hits the limit because the GitHub Actions runners they're quite inconsistent. You can run the same payload on one instance, it takes 3 hours, then you run it the next day, it takes 6 hours, and you hit the limit, and then you have to retry it and wait another 6 hours. But we build this for all these 4 configurations. Then we also cross-compile on Linux, cross-compile LLVM for Linux on AR64, so we can build the binaries for that as well. We take the output from the assertions toolchain and cross-build FFmpeg on Linux, 9 minutes each, more or less. And this will you will only find the broken assertions in this build. No information about actually, runtime errors. Then when you have the toolchains that will run on Windows, we have this set of jobs on Windows, running my own set of small tests, 2 minutes, on x86, 64, and 32-bit. We run FFmpeg tests on actual native Windows. So this will actually catch some of the breakages in runtime behavior if it shows up on x86, 64. We run the compiler RT, that is the sanitizer tests, and OpenMP tests. I have a setup for libc++ as well, but I usually don't run it since it's also included in their own CI. And if all of this completed except the ones that aren't connected, then it will upload this as the latest nightly, so people can try it out. This used to be like a big issue before, because if somebody had filed an issue, I fixed the issue that they had a concern about. I want them to test out that is the fix actually good, and then you need to ask them like, okay, I can make a build for you so you can try out the fix. But do you want a Linux build? Are you using it as a cross-compiler? Do you want it on macOS? Or do you want to run it on Windows, in which architecture, and so on? So, I mean, it used to be that when I provide a fix, I need to do 4 hours of compiling to give somebody something to test. And now, just tell them, within 24 hours, if things go well, just go grab the latest nightly and try that instead. So, that's all for me today. Any questions? Yeah, Steve?
Yes, first of all, thanks a lot for your work. It changed my life. As soon as PDB support was added, it saved me hours, every day, and I use your tool all day long, every day. So thanks a lot.
Thank you.
You mentioned that there's LLDB support in IDE. In what IDE is it supported, and what kind of support do you get?
I have actually very little clue myself, because I don't really use IDEs much. I have people telling me that it does work in VS Code. It does work in Qt Creator. It does work in, I'm not sure about the others, but people have told me that they are working on setting it up in those. And there is some issue on my GitHub page where somebody has tried to make examples of this is how you set it up, but I haven't really tried them myself, so I can't really say. But most of the modern ones do work, I think.
I have another question.
Yep.
For JP. Since there's so much testing going on all the time on that toolchain, can we switch to LLVM instead of GCC for VSDBs and those?
I think that's the plan, yes. De facto, GCC is dead. I mean, de facto, like iOS, macOS, and Android are LLVM. Windows now can produce with LLVM PDBs. All BSDs are LLVM. All consoles and weird things are LLVM. So, like in 8 years, it moved to almost everything GCC to, well, we're doing everything on LLVM, and that's life. Like, pragmatism won. Okay, guys, we're late, so thank you. Are you good? Yep. Just a small remark for the people who really need coffee. There is a bit of coffee outside, but don't go all together. Thank you.
Hello, good morning. I'm Mark. I'm with Meta for a little bit more than 3 years, and I'm part of Video Infra org. So just to give some sense of scale at Meta, while I was not able to find public information about number of hours video watched, but we do have about 2 billion daily users on our platforms, and of course they spend a lot of time watching video and generating video content. And Video Infra org, as the name suggests, provides infrastructure, services for video creation, delivery, and playback for Meta apps like Facebook and Instagram. We also provide APIs for third parties, allowing them to build video services and use FBReach to distribute their content to billions of users. And we use FFmpeg-based transcoder for various video transformations, and I want to take this opportunity and thank the open source community for providing such a great tool. I'll be talking about usage of FFmpeg for live services, and I'll be talking as a user, focusing on our use cases and challenges we had in building a reliable real-time infrastructure serving billions of users. If you have questions, feel free, raise hand. I'll do my best answering. So first, let me present on a very high level the simplified data flow to set the context on where FFmpeg is used within the ecosystem. So we start with the broadcaster that starts a live stream from his mobile phone, let's say using his mobile camera. And the video signal is hitting the ingest point, which is closest to the broadcaster. And then the data will be forwarded to the closest or available data center to a live server. Live server will determine the amount of resources required to execute the job, and will ask resource broker to allocate job based on the needed resources. Resource broker will find the available host in the local data center and will start FFmpeg-based transcoder job. For live operation, the video transformation that we do is to generate ABR from a single input. Today we use FLV over RTMP as input and output to FFmpeg. And we are working on migration to RASH protocol, which is a more efficient ingest protocol, and is currently in the draft stage in ITF committee. But it's not very important in this context. So transcoder will output multiple ABR lanes, and this will go to a separate process on the same host for MP4 packaging. And then it will go to manifest service to generate dash segments and manifest, and then to CDN and player. So in this talk, I'll be focusing on use cases around FFmpeg. So we have to generate live ABR. So what are the main challenges we have with live ABR generation? Not in particular order, all these are requirements we have to meet. So we have to generate multiple quality lanes for ABR. And as you know, the idea of ABR is that player can select best quality lane for playback based on various conditions like available network bandwidth. And it has to be able to seamlessly switch if network conditions change. And in order for players to be able to switch seamlessly across lanes, we must generate segments that start with IDR with the same PTS and with the same content. We are talking about live service, so low latency from broadcaster to player is very important. So we need to have ability to monitor and optimize latency. For live, we also must provide uninterrupted service in real time, so we must reserve sufficient resources required for the operation to be successful. And we also must make sure that we don't waste resources. We don't want resources to be wasted. Even for Meta and their own data centers, we don't have unlimited resources. We always try to optimize resource usage, either to reduce cost or use these available resources for new services. So let's dive deeper into the issue of lane synchronization. Our typical ABR letter will have a few transcoding lanes, a thumbnail lane, and sometimes we'll do pass-through lane, and sometimes we'll do only transcode, and we'll use FPS filter. I'll talk later about this. Now, I'd like to focus on the pass-through. So we'll use pass-through lane only if it passes various validation like bitrate, frame rate, GOP size. We do not want to send something unreasonable downstream. And by the way, we consider pass-through lane because it allows us to save CPU and provide better video quality to users. So if PST is good, we'll use it. And then we have to align IDRs on transcoded lanes to match IDRs on the pass-through lane.
What PST, sorry?
Pass-through lane. And we do this by adding a flag force keyframes, source all, to all transcoded lanes. Let's see, I lost it in the slide, so all transcoded lanes will have this extra flag. So we have full flexibility how we generate our FFmpeg command for ABR, and we could create lanes that are not resulting in aligned PTSs. FFmpeg internally will not try to fix or warn us because it's completely outside of FFmpeg's scope. It's the responsibility of the application to make sure we configure FFmpeg in a proper way for ABR use case. So we use the following flags to manipulate the timestamps. We use vsync VFR, copy TS, and enc timebase -1. And the idea is that we want the timestamps on the output will match as much as possible the timestamps on the input, and we want to avoid any unnecessary time-based conversions. And I'll explain later why. For thumbnails, we'll use a file name that includes PTS, and this will allow us to synchronize thumbnails with video. We have use cases when UI will show thumbnails, and there is expectation that once user clicks on the thumbnail, it will jump to appropriate section video. So we use this scheme to achieve synchronization. So the scheme that I showed, it almost works, but it's not sufficient for some corner cases, and these are related to audio transcode and FLV. So anyone has idea what can go wrong with this? So what can happen is with audio transcode, for example, if you use HEAC, there is a priming section, and this can result in negative timestamps for audio, and FLV does not support negative timestamps. So what can happen is some lanes will get negative timestamps. Max is going to fix this, and then some lanes are fixed, some lanes are not fixed, and then we out of sync. So to solve this problem, we actually shift timestamps before sending to FFmpeg, a few seconds in the future. And also, we run various validation and fixes on timestamps generally before sending data to FFmpeg, because we want to avoid sending something bad downstream, especially with PST lanes.
Why are you using FLV then?
For historical reasons. We are migrating, as I mentioned, we are migrating to Rush, so these issues will go away soon. So next, I want to talk about latency. So latency is important for live, and we classify broadcast to different latency tiers. We have starting from ultra low latency of about 2 seconds end to end, and we have tiers like low latency of 4 or 5 seconds and regular 7 to 10 seconds. Of course, there are trade-offs between latency and quality and reliability. So, for example, we'll pick ultra low latency. We'll not use B-frames for this configuration, and we'll apply it only on a good network. And when we talk about latency, we talk end-to-end latency, meaning from broadcaster to player. And as you can see, the signal is going to go to multiple devices, multiple data centers. So in order for us to meet latency target, we have to be able to monitor and analyze where the latency is spent. And in all this end-to-end ecosystem, FFmpeg-based transcoder is a subsystem, and my team is focusing more around transcoder, so we are also interested in what is happening inside the transcoder, so we can optimize various phases. So to measure latency, we will periodically mark frames with some unique ID, and we monitor the life of this frame end-to-end through the system. For first-party clients, meaning like every Facebook application, when we own the broadcaster application, we'll insert this frame ID in broadcaster phase. And for third-party clients, when it is external encoder, we'll insert this ID in ingest stage. So initially, we carry this ID in some non-standard method extending video bitstream in a non-compliant way. We could do that because we own both sides, the server and the player. And now we are working on a more generic scheme when this ID is carried on a container level, so it is codec independent and easier extendable. So some more details about implementation of this frame ID scheme. So initial version, we utilized packet and frame side data. We extended decoders and encoders to extract and reinsert frame ID as a side data. And it was codec dependent scheme, so every codec that we support, we had to extend. In second version, we worked on PTS-based packet tracing. This scheme is codec agnostic and worked very well. And we also started to carry frame ID in container level. And we have a proven example that this scheme works well because we sort of got for free latency monitoring for our ASIC-based transcoder. While it worked well, we had some challenges when dealing with invalid inputs, where FFmpeg would detect invalid timestamps and it would correct them, and then we had harder time to trace frame based on PTSs because PTSs changed, so we had to trace when it was changing. So with introduction of a pack pass-through, what Anton presented yesterday, we probably will look into the scheme, and hopefully this will allow us to simplify the scheme. But we'll still have some changes around for the ABRs with when we use frame rate conversion. As part of frame rate conversion, we want to make sure the frame ID is preserved correctly. We don't want to drop it. We don't want to repeat it. So we'll have to do some work there. We basically want this to behave similar to ATC A53 closed captions. Okay, so we discussed how we can measure latency and see the bottlenecks. So now we can start looking where the bottlenecks are and how we can optimize. So we observed that transcoding every lane in a separate thread can help reduce latency. And we developed internally transcoder that is using FFmpeg libraries for core operation, but is implementing our own orchestration layer for multi-threading. So while this helped us to reduce latency to the desired targets, but this application started to grow with more and more features, and with time it got to a state when it is hard to maintain, especially with FFmpeg upgrades. So we are super excited with ongoing work on multi-threading, and we're really hoping to get it very soon. We are currently in the phase of designing out our internal transcoder and start using FFmpeg for live operation. And this is one of the critical things that we need to have resolved before we can do that. And actually, while we do evaluation, we already saw improvement in latency in 6.0 comparing to 5.1. And while we could not very clearly explain why it happened, we knew that multi-threading work is not done yet. But again, in yesterday's presentation, I explained that Dmax and Maxer already have multi-threading, and then it explained perfectly what we observe in our testing. So, thank you. Okay, so we touch about latency measurement optimization. Now let's talk about resource estimation for live operation. So differently from file-based, we must have minimal resources available for real-time operation. So we must know upfront how much we need. And as I was mentioning, we have multiple output profiles, different number of ABR lanes, different quality levels, different latency. So to estimate how much we need to have some model that on input it will take input properties like resolution, bitrate, frame rate, and output profile. And on the output it must say, okay, you need so much CPU. And we also have different machines in data centers, different CPU architecture, different caches. So we also have to scale this number to match the target hardware. So in order to do this, we do this estimation actually before we start a FFmpeg process. So we have to, yes?
So you don't do any content checks at all to estimate CPU usage, just based on?
Correct. At this stage, we just look at the metadata. We don't decode at this stage.
You haven't considered like, because some clips take twice as long CPU-wise just because of complexity, and that's a dominant factor versus.
Correct.
So I'm surprised you haven't done that.
So I'll touch a bit about this as a problem. So we collect some input. We have to collect some input properties, and we have to do it before we start the job. So it means we have to analyze input for some time before they start the job. And then we start a FFmpeg job, and FFmpeg also works to analyze data to decide how to run. So we actually pay latency twice for the action of analyzing the input and seeing how to process it. So to reduce latency on the FFmpeg side, we use flag FPS prop size of 5. So this helped us to reduce startup latency from default settings. But we could not go lower because we saw some regressions. And these 5 frames, it adds 100 plus milliseconds, which is not negligible in case of low latency broadcast. So if you had a way to provide the input properties over CLI to FFmpeg, this would help us to save these milliseconds at startup. And as you correctly mentioned, the CPU required for transcoding hardly depends on content. And when we do the estimate, we cannot estimate for the worst case because it will be too wasteful. So we estimate sort of for the average case, and yes, we run at risk of running out of resources. What is planned for us is that we run multiple sessions on the same host. So on average, I mean, it is not likely that we are going to hit hard content exactly the same spot, but still there's a problem. So if you had a scheme where transcoder would dynamically adjust use cycles to some specified budget, or if you had a way to reconfigure dynamically a transcoder based on whatever content based on our real-time performance of the host, it would help us to save on resources as well. Yes.
So this exists, right? Like, this is the speed control patch in X264. It's been around for 10 years, maybe 15. Like, it's how we use it for television, for example. Like,
Okay.
it already exists. So I'm a bit surprised you're saying there's a proposal. I mean,
So I'll follow.
we have tens of thousands of services on there with this patch
Okay, cool.
doing exactly this.
So-
But Kiran, it's not exposed to that template though. My understanding is that the API is.
No, it's an X264 API, and it was never merged as well. It's an external patch set.
Okay.
So it isn't available.
I mean, it's an X264, so
Yeah, but it's an FFmpeg. Like within FFmpeg is not available as an option yet. So if it was available, it could be used, right?
I'll no,
but by definition, it's an API call to reconfigure, right? And how do you pass real-time API calls to X264?
That is the question.
Through FFmpeg.
No, but FFmpeg doesn't know about what X264 is doing inside. So
Hence the proposal.
no, but it can't just magically know what X264 is doing inside, right?
But-
X264 is a black box to FFmpeg, right? So how do you propose that you want FFmpeg to know what X264 is doing inside?
But we can monitor externally, basically how far we fall behind on CPU, and then if you see that we are falling behind, then we could trigger some feedback.
Yeah, but X264 does this already in the speed control patch.
Okay, so I'll follow up with you about this. Thank you. Okay, so another angle of resource utilization. So as I mentioned, we generate ABR of various complexity, and the larger the job size, the harder it is to bin pack these jobs into CPU. So for example, here we have an example where a single ABR does not fit a single host, but if you were to split ABR into multiple hosts, then you'd be able to schedule this job. But with this approach, there is a complexity of dealing with a restart of a job that represents a subset of ABR, as we need to make sure that the output is still resulting in aligned IDRs. So basically, we need to solve the problem of given transcoder output, we have to determine what input section we must retranscode and with what parameters, so the output will be aligned with already running job. And this is where we need the live server to know to map from output PTSs to input PTSs. And the simplest method for mapping would be if the timestamps are the same. Okay, so let's see how we solve this problem. So option one, we had it with our current internal transcoder, is live server would dictate on frame level for every frame what to do with it. Encode, drop, what PTS to put IDR there, yes or no. This is most flexible, but it is hard to maintain. So now, as part of migration to FFmpeg, we are thinking how we would solve this problem in a less intrusive way. And So what we want to achieve is to configure encoder FFmpeg. We have to pass to FFmpeg the following parameters. We have to tell what frame to start with, what PTS the first frame should be, what is the desired FPS, and what is the desired GOP size. And once we do that, then we'll be able to achieve aligned ABRs between regular lane and restarted lane. So here, let's take this as example. Actually, what is interesting, when I was working this presentation, I found a bug in the scheme while trying to show what must happen. So we changed the approach. So I'll show the bad usage and the good usage. So about the example. So what we have here is on the top we have a lane that we want to achieve. We have IDRs let's say every 5 frames. We have timestamp there, and we go from 30 FPS to 20 FPS. And we want to generate an output IDR every 6th frame. And let's say restart happened after frame 367. And restart can happen for various reasons. It can be that we upgrade host and we have to migrate broadcast to another host, or it crashed. So many reasons could be for this restart. So we are starting a new job, and we want that the new job will generate aligned output to the lane that continues to run. So basically what we want to generate is the first frame should be, the source should be 233 and output should be 250. So in order to achieve that, we have to start sending to the new job input starting from frame 133, which is the IDR. So the decoder must be able to decode. We have to tell it that it must drop first 3 frames. It must start with frame 233. It must set the PTS for this frame to be 250, and it should run in 20 FPS. So what we were doing originally, we said, okay, we'll just follow what I said. We drop first 3 frames, we set FPS to 20, and we set PTS of the first frame to be 250. This almost works, but with this scheme, what would happen is that frame 267 would not be dropped, it would be encoded, and then we'll get out of alignment from the main lane. So the proper fix would be actually simpler, and we can use start time feature of FPS filter, and our testing showed that so far this works well for the corner cases that we saw. Any questions? Yeah, this is it. Okay, I have one last slide. So to summarize, that's what we talk about. Our timestamp model that we are trying to achieve is that output PTS is matching input PTS, and we use it for ABR alignment, we use it for frame tracing for latency, and we'll try to use opaque parser to simplify the scheme. We'll use it for, once we start looking deeply into behavior of timestamps, we actually, as a side effect, we implemented the media validation, and if we detect bad streams, we can report it to upper layer, and usually the stream will be rejected. We don't want to send bad stream downstream. We use it for monitoring. Optimization opportunities, we talk about double probing on FFmpeg and live server to get the input properties. Changing encoding profile, thank you for your proposal, I'll catch up with you. Splitting ABR to multiple hosts helps us with better usage utilization, and we are looking for multi-threading to complete migration of this project. Thank you. Any questions?
Contrôle L, non? Good morning.
All right, second time this conference for me. Hi everyone. Today I'm gonna talk about something a little bit different. And this is a talk extracted from my work actually, well, kind of. So I don't actually claim authorship on this. Some other people have made similar presentation in other contexts, so it's possible some of you have already seen this kind of thing. But anyway, this is all my personal opinion. And it's a little bit controversial, so please let me finish. You can raise questions at the end if we have time, which we might not have, but anyway. This is going to be C code mostly, and the reason is I think this is what's most common to the audience, but should know that this also works with C++ or with unsafe Rust, and I'm using C99 syntax. So we are going to have example code that always assume we have this at the top. There's nothing interesting here, we just have a show function which prints its parameter, but if you want to test this at home, you need to use this at the top. So, with that said, that's 1 minute. So, what does this do? Well, so we create two arrays of one integer each, and the second one we initialize to 12. Well, its only element to 12. Then we take a pointer to the end of the first array, which is allowed by the C specification, and a pointer to the beginning of the second array. That's the second line. Then we convert each of those pointers to an integer of pointer type, of pointer size, which is again perfectly well defined if the target implements unptrt. So far so good. And then we compare those two values we just computed. And if they're equal, we do this, perhaps the weirdest part of the code so far. So we convert back the second integer into a pointer, which is again allowed by the spec. Then convert it back to the right type of pointer because this was void pointer. Dereference it, assign 42, and show the value in the second array. Now, if you follow, you'll notice, of course, that E2 points to the second array. So when we assign 42 there, we replace the value in the array. Therefore, show will print 42. So what this code did, well, if I1 and I2 are equal, then it prints 42. Otherwise, it doesn't do anything, right? Yes, and I tested it. Which, you know, yeah, it's a little weird that it does different things depending on the optimization, but in this case, I think it's actually correct. So, first change. So this is the same code. Let's substitute equal values. So, I mean, if I1 and I2 are equal, we can obviously substitute I1 for I2 inside the if block. No problem. Both expressions are of equal value, equal type, and they don't have any side effect. So we can do this. Then we can again do equal substitution. So we replace I2 by its value, which I1, sorry, by its value, which is A1 end. Cast it to unptr2. And yet again, now it's starting to be a little bit too long. So we replace A1 end with its original value, which is the end of A1 array. So A1 plus 1. We get this. Okay, second pass. Okay, we skip round-trip type conversions. Because, I mean, yeah, it started to be a bit unwieldy here. It's a converter to void and to unptrt back to void. We can remove one set of conversions. We remove the unptrt conversion, essentially. We get this. And we can also remove the in pointer to void pointer to in pointer conversion. And we get this. All right, pass 3. Constant propagation. Okay, I'm just adding, nothing interesting really here. I'm just adding a const in A to begin because we see that we never actually dereference the pointer we get from that. And this is a more interesting bit. So as we can see here, the A2 array, which we have initialized to contain one element equal to 12, we take a pointer to it, but we never modify that pointer. I mean, we never dereference that pointer, so obviously we don't modify it. So A20 is necessarily equal to 12, so we can substitute to 12. And at the very last bottom, in the show instruction. So we get this. Okay, now what does this do? So if I1 equals I2, this prints 12, otherwise it doesn't do anything. And there's a problem here, because the two programs are supposed to be strictly equivalent, because the only transforms we did were all legal according to the specification. So one explanation that we can have is that this is an absurdity, and obviously that means that I2 and I1 cannot be equal, and the compiler always has to assume that they are different, which would be a valid explanation. The problem is, as we see here, GCC sometimes do treat those two pointers as equal, and there's a very good reason they are going to be allocated. Those two arrays are going to be put on the stack next to one another, so the end of the first one is going to be exactly at the start of the second one. And we can generalize this. So let's remove the first array, because we really never use the first array. Instead, we're just going to find the number, the I1 number that was generated by the first array, by just having an infinite loop, or an almost infinite loop that will iterate over all the integer values. So this is what we would have at the beginning of the talk, if we had done this approach instead. And yeah, if you do this, you'd better enable optimizations, because if you don't enable optimization on a 64-bit CPU, it's going to take a couple decades to run the code, but eventually it's going to print 42, because eventually it's going to reach a point where I1 equals I2. If you do enable optimization, the compiler is going to figure out that there's only one iteration that actually has anything to do, so it's going to remove the loop, and the code will run very fast. And that's what happens. I think on a 32-bit system, you could probably complete it with a somewhat reasonable time, because there's only 4 billion iterations to do, but I didn't try. And you can do all of our 3 optimization passes again. This is what we would get, following the same logic. And again, well, again, it will end up the same stupid thing that we will show 12 and we just said that we have to show 42, which doesn't make any bloody sense. So how do we fix this? First solution, obviously we forbid using new in PTRT and in PTRT. That's actually possible. The C-spec says that this is an optional feature. Since it's impossible to implement them correctly, obviously the only way to follow the spec is to not have them. It's not very practical, maybe, because I think every operating system needs this for, virtual memory management, and also every heap implementation needs this. We could also forbid substitution of integers by equal values. This does cause some issues in compiler implementation, and compiler authors will hate you if you propose that, because then it means that x minus x is no longer equal to 0 for x an integer. And it turns out that this breaks a hell of a lot of valid optimizations. We could also forbid indiscriminate substitution of pointers, which means substituting one pointer for another pointer where the two pointers are equal. Well, if we do that, we can't do aliasing optimizations anymore. It's not very good. So basically nothing works that makes existing compilers conformant. So all the solutions anyway would break existing compilers. And the C community doesn't like to make changes to the spec that would make current compilers no longer conforming to the specification. So the least insane solution is to say that if you have a pointer and then you've converted it to an integer type of suitable size, and then you convert it back to a pointer, then it's no longer subject to aliasing optimizations. And in this case, this would mean that we would always print 42, and we would not be able to do our constant propagation at the end. The problem, again, is that this would break existing compilers because, well, as we've seen with GCC, it does this optimization, and now we're telling you can't do this optimization anymore. And this is, again, a problem that the C community doesn't like to break existing compilers, and this is why we cannot have uint 128, because this would break the ABI and break all the existing stuff. But this is what is known as the pointer provenance problem. So if you've heard that expression, now you know what that means. And that was the title of the talk, by the way. Any questions? I have 9 minutes and 30 seconds. I did not try with Clang, but another author did it and it has the same problem.
So, hello, my name is Webex, and I'll try to speak fast about fast reading of bits. So, really, all I want to focus is on almost sciencey stuff and why it goes fast. And really, I'm not interested about API, security. There are people paid to do that. So that, I guess there are people that can give a lecture on that, so probably I'll just explain why we do that. So we want to transmit stuff, we want it to be fast, so we want it to be small. So what we do, we try to see if we can squeeze shorter bits for some terms. So there's a page for Wikipedia if we want a quick explanation. You can somehow say there are strings of bits that are kind of independent, and that tells you, okay, that letter is quite frequent, so it should have a shorter stream of bits, and that's how you do it. So, for instance, on that sentence, this is an example of Huffman tree. You can somehow encode that in 147 bits instead of more. We don't care. The real example is more for image coding, where a lot of stuff basically generates 0 or 1, and maybe 2 and maybe 3, but those are quite rare. And this is kind of operation distribution, so really you want to be efficient in coding 0 and some other small stuff. So how do you do that in FFmpeg? You're not going to do bit by bit reading. You're actually going to use tables. So the idea is that you are going to fix a fixed amount of bits, and in there is a code word, or maybe not. But if there is, you know that its part, its size is fixed, and you know the prefix, that meaning it's unique, of the code word, and there are bits we don't care about. So what you do is say, okay, I have an integer that is made of a prefix, which is a code word, and bits, we don't care. And you build a table out of those integers. You read n bits, that's an integer that goes up to 2 power of n, and you map that integer to the symbol you want to decode and the number of bits that are actually there. So what you do, you've seen an integer out of the bit stream. It's that value, it points to, this is the symbol, this is the number of bits. Done. So in effect, there are symbols that are much longer, code words are much longer, but it's not interesting because they are slower and quite less frequent. Okay, so this is a better explanation if you didn't understand a word of what I was saying. This is a pure example. There are cases where you have an integer that is directly mapped to a pair of a symbol and a number of bits. You can build a table, for instance, a second code word is made of some bits and 3 that are completely random, and all entries in that table map to that symbol, and you're done the decoding. And the last bit, sometimes you can't do. So here you require more bits to be read, and you have other parts of the table that will give you how to decode further bits. And you continue on. So, I'm going to be quite fast there because it's going to be a bit difficult. So I'm basically explaining why. So the real important part is that even those building of tables are speed critical. So you are going to try to optimize things in that. So for instance, you know the distribution. So once you're over some limit, you know that you don't need to look further up about how to build that. This so very old code for me. I mean, last I looked at that, it was 2017, so sorry if things have changed in how it is built. One thing that is interesting is that this table is made of a 16-bit code and a 16-bit length, because you could put that on 8-bit, but that's not easy for x86 address computation. So you want to do things that are quite simple, not have multiply and things like that. Okay, so the real interesting thing that is from 2007, nobody in FFmpeg ever thought of porting it to anything else. And it was dual reading of symbol. You have prefix code, meaning that when you read a bits of a symbol of a code word, it's unique. And it means that 2 symbols are also unique, a pair of them. So when you read several bits, you can have several code words in that. And you can actually decode several symbols by, when you read that. So it was quite limited in the past because you had to fit 2 symbols into a 16-bit pseudo symbol. So it's not critical because most of the symbols you want to decode are often associated to symbols that are small in magnitude, so they fit into 16-bit. There are some rules to apply, but it works. So as I mentioned, this was implemented in 2007 by an evil penguin, for those that remember him, or ever see him or heard him, I don't know. And that was already a 30% speed up over the kind of smart reading of bits I presented before. Okay, and in fact, you can do more than that, a bit more complex. I mean, why stop at 2? You can go up to 11. So in that case, it really matters that you have some limit on the table you want to build. So it's kind of work in progress. That's something I came up with, which seems like the simplest. You want 8-bit data structure to hold that kind of stuff. So what you have is up to 6 symbols and the number of bits that are read for those 6 symbols and the number of symbols. So what you do is you have your integer, it points to a table. Okay, so this is the symbols. I put that into the output buffer, and I know the length, and I know by how much I have to forward the buffer pointer. Expecting it's not a UN pointer, and there's no problem with the compiler, obviously. And obviously, there are cases where you won't have enough for even that. But that we don't care. Those are rare. It can be left to something else. So what did that cause? I would say that it needs to be further studied. Paul Mall recently re-implemented that in FFmpeg. And I would say that it's at the very least 10% faster than just 2 symbols at a time. There are other drawbacks to the old methods because it was always trying to read 2 symbols at a time or things like that. But really, what happens is sometimes you have a very rare, very long code word that causes a mess, and you just want to skip it to go back into the fast reading. And that is actually quite provide quite a big speed up. Okay, going forward. So I would say that it relies heavily on the bitstream reader. So it was a huge topic like 7 or 8 years ago. There's Alexandra, sorry, I don't know how to pronounce that, Sashka, that did a lot of good work with people at that time in a particular project. And there are also blog articles from a guy that is really smart and has proposed various variants that are trade-off in code size generation and speed. I would say that David has some kind of a cousin of that bitstream reader, and it's because of that that we are fast. And as a result, I would say that this is maybe for kind of toy codec, near lossless, but on those it's absolutely a blast. It's easy to get 30 to 60% faster decoding for those who cares. And our last bit is ProRes, so please don't sue me if I didn't put enough symbols, weird symbols. It's a JPEG. I don't know why people keep on piling JPEG variants, but that's how it is. And it tries to be smart for maybe 1% coding gain efficiency. And it's absolutely horrendous to deal with it. If you do it the not least smart way. And what it does is change all the symbols are depending on the previous result. And you can just use VRC again for that and take that into account. So last I've tried, which was maybe 2 weeks ago before I was scared by people asking me about APIs and security, was maybe like 40% speed up. And that concludes my talk, and I have no idea how much time is left. And anyway, thank you guys for building this up.
I have a question for Simon related to this presentation. Do you know if the VLC name was selected because of VLC or not? Or just like lucky mistake. Okay, thank you very much. Merci, Christophe.
All right, going to start my timer. My name is Frederick, I'm from SVT, and I'm going to give you the least technical talk of this weekend. Quick disclaimer before we get started. When I'm saying SVT, I am talking about, what'd you say? Sorry, I thought I heard something. We are not Intel. We're a Swedish public broadcaster, kind of like the BBC. We produce content, we broadcast linear content, we do streaming online, and we were first, so, you know. Here's the thing, like everyone else who does online video or video at all, we rely quite a bit on open source software, the things that you guys in this room all make. Like, I basically threw a bunch of logos together to show you the entire backbone of basically all video processing we do. So thank you very much for doing what you do. We love your work, keep at it. But we didn't want to be greedy assholes and just, you know, take your hard work and not give anything back, because that's not a very nice thing to do. So we started discussing, how do we give back? First we were like, can we finance these projects in some way? We're tax funded, we can't do that, I'm very sorry. But then we thought, hey, maybe we can like push bug fixes, add features. None of us are really C devs in our team. We build workflows. We don't do assembly hacking and making really cool compile time optimizations. So we started talking to people in the community like, hey, what are you guys missing? Especially you guys working with open source, open research, that kind of thing. And we got a very good result, which was test content. We found out that there's a big need for test content that is to a modern production standard and that's not license encumbered, because there's basically two camps these days. You get content that's free to use, it's really open, but it's really old and it's like 1080 at best, or you get like really high-grade content, but it's kind of license encumbered, which is like, if you're a big streamer, it doesn't matter, you have your own content, but if you're a researcher at a college or you work in open source or you want to compare stuff, then it's an issue. And that we can help with. We've been doing TV for more than 50 years. We have a lot of experience in producing content, and we also share it openly. We did this in 2006. Some of you might recognize extremely well-known sequences like Ducks Take Off or Crowd Running. That's us. We love them. So we thought, let's do that again. We released a suite about a year ago, I think. It's called Natural Complexity. And it's basically a bunch of content that we made ourselves to stress test encoders for our own purposes. And we decided, hey, let's release that under a Creative Commons license so that people can use it. There's a lot of technical details, but basically, the pointer's not working. Oh, there we go. We tried to do a modern sort of production standard. We have ACES material. We deliver it in Rec 709, Rec 2100, with very high data rate formats. So we have EXR, we have JPEG 2000, and lossless YUV 444. High bit depth, high resolution, 50 frames a second, because that's sort of European broadcast standard, filmed with modern cameras. We basically just took a bunch of cameras out into the countryside and started filming stuff, and hopefully that's good. There are 6 different sequences, and then we have like a main one that's sort of an edit of all of it. You can read more details in our white paper that's available online. But basically, we just filmed stuff that we know stresses encoders out. Smoke, fast-moving water, low contrast textures, small objects moving in the background, very, very high dynamic range, that sort of stuff. It can really mess stuff up, that we found when we try to compare it to commercial encoders. But it's not perfect. As I said, we just took a couple cameras out into the countryside and filmed a bunch of stuff. We don't have any videos of people yet, so if you're interested in encoding faces efficiently or whatever, we don't have that yet. We don't have any camera movement. This is all static camera footage. So if you're looking to fix like interlaced bugs with panning or stuff like that, sorry, can't help you yet. And I'm from an HCI background, and at my work we do a lot of evaluation with actual humans. So it's kind of a problem that the content isn't very engaging, because then people don't look very critically unless they're video experts and care about this stuff, right? So if you're talking to quote-unquote normal people, they might not be looking really hard at the video. That said, we're open to suggestions. Send us an email if there's anything you feel is missing, and we'll try to get some more cameras out. The files are hosted at this URL, svt.se/open/content. It's both the new suite and the old suite. You'll find white papers, you'll find servers with the files, all that. That said, the files are hosted on an FTP server right now, because that was the easiest thing to set up. Our security guys are really mad at us about that. So we're looking for help with hosting. If you or an organization you're affiliated with think you can help.
It's there in SIF, media.sif since 4 months.
Yeah, okay, yeah, it's on SIF as well. But, you know, just like Big Buck Bunny, the more places, the better. So if you think you can help, shoot me an email. That's it. Thank you. 6 minutes.
I have a question.
Yeah.
Yes. Sports. Do you know how many man-hours Ducks takes off that's wasted?
Hopefully more than you think.
Oh, you have no idea.
Can we have sports content? Actual sports.
Depends on the rights, but maybe we can just take a camera out to some kids playing baseball or something, and that could be interesting.
I think I said actual sport.
All right, we'll go to a rugby game or something.
You do ball? Okay. How do we do this? One sec. So we are trying to do something quite complex. No, we're doing poll. We cannot block it. Okay, how do you do that? We are trying to do something a bit complex. Don't see. Don't worry, I'll call you after, Lynn.
Okay.
Paul?
Hello.
Can you share the screen and start?
You need to unmute the sound. Talk, Paul.
Hello.
You need to share your screen.
Okay, yes.
It's interesting because the screen share worked on my PC.
Can you share your screen?
Can you share your screen, Paul?
Pierre?
Tell me what option to select, because I don't.
So as you understand, we're trying to get Paul to speak, which is
I don't see
difficult.
link.
So
It was working before.
yeah,
so
of course it was working.
do what you did before.
So we are going to skip to the next one.
Okay, they're gonna skip. They're going to skip you, and then you will do it next.
Paul, we are coming back in 5 minutes.
That's not a screen share. That's a camera, I think, Paul.
Yes, I will see.
Hi, I want to present a small experiment that I wanted to do with VLC. So VLC is known for playing anything, so I wanted to know whether I can play actual
So,
games with VLC.
let's try and fix this.
So, I wanted
Was
to
working
show
before. So this
see
is your
if you can
camera,
run
right?
an actual emulator in VLC. So my rules was was not
There is
going
some
to make any
picture of-
modification
no,
to
maybe the
VLC
room.
core. I decided to run a Game Boy Color
that's
emulator
your
in VLC
stuff.
because
I
mostly that's kind of a
that's
small
the-
platform, easy platform.
So you
There's
need
no
to share your screen.
OpenGL or whatever. There's simple video, simple audio,
not.
and
See me
it's
sharing the screen?
really few controls, just things like a
see me
D-pad
share?
and 4 buttons.
You need to do the same thing. You
So,
had it working
what do we
before.
need? First, we need an emulator implementation. We need video output, audio output, control input, reading a ROM, and pacing. So, we already have some modules that are kind of interactive within VLC. For instance, we've got video projection for 360 video. We've got, but that's kind of the very end of the chain. We already have video, and it doesn't deal with audio. Same issue with, for instance, this is
What does it
the
say?
puzzle filter. It's not really, you can't really see, but that's only work on.
Wait, I need to
certain
move
type
to
of-
another
of
workspace.
stream.
So this
So
window
you already
manager
need to have
thing.
video incoming.
Oh, you have
so
two core models now as well.
there is a third one, which is at DMux, when
other
it's
thing
used,
we
for
need to sort
instance,
out is
for
sound in that
DVDs
room.
and Blu-rays, and you can kind of control them. So it looks good because you're right after the access, so you can pretty much access files from any sources, and you can declare tracks, you can paste things, and you can interact. So that was kind of good candidate. So yeah, basically what I said. Then I needed an emulator library. I decided to use something called Game Boy Core, mostly because it provides kind of a simple API. It's really, really straightforward. It's really not the best implementation out there. There is a lot of crash, there is a lot of artifacts. Texture are flipped upside down, but it doesn't matter. It was just a proof of concept.
Otherwise, we can just show your slides and then you talk. And then
So file input.
We'll change the slides for you.
ROM size for Game Boys are really small, so last less than a megabyte. So I can just when I'm opening my modules, I can just read everything and pass it to the emulator library. So it's kind of straightforward. Pacing. Game Boy is fixed rate, so I can just declare video tracks, and it says that it has a certain frame per second, which corresponds to the hardware. And I will run the emulation until it produces the frames, and I set the PTS on the frame and send it down the pipeline and repeat as well. So basically, I'm just running the loop, running my emulation until I've got a VBlank, which corresponds to a whole
or should we just show the slides?
being completed, and every time I just run instructions, and I convert between string sticks to video to VLC text.
Maybe
and I send it
reboot
down
your
the
computer?
pipeline.
No, it's not
So,
about
regarding audio and video, as I said, it's quite straightforward. That's raw data. It's provided by the library. So, for instance, for video, every time it's end, you have a scanline, you get the raw buffer regarding the scanline, and at some point you got a VBlank, and you send. You can know that you have a complete frame, then you can send it. And audio is pretty much the same. You have blocks that are coming, and so that's kind of easy. So, you've got VBlanks,
background,
and you've got the skyline. You can just copy it to a buffer and send it afterward. User input. That's where the fun begins. So there is things related to navigation, like we did for DVDs. That's kind of cool because you have left, up, directional, and you've got some buttons. But the issue is that that's only transactional events.
To
You
just
don't
start,
have state whether the button is hold or not. So that's really not useful because you can't just
I thought you were going to show reverse engineering
or something like that to know that you're pressing.
But you can't see it.
To press, for instance, the left buttons. Okay. So, no press state. That's really an issue.
Unless you want to use Zoom or something.
Mouse inputs. So that's better because you actually have the press state. You know whether the button is pressed or not. So you got basically 3 buttons usable: center, right, and left. And you got mouse wheel, but you can't really press a mouse wheel on your mouse. That doesn't make sense. So in the end, you have things like 3 usable buttons. So but the Game Boys need 4. So just ditch the select buttons. There is no use for it. Well, regarding direction, you have to be a bit creative. So what I did is that I have the position of the mouse within my video frame, and I can just say, oh, if my mouse is on the left, I will go left, and it's in the upper left, I will go up and left. Okay, that kind of works. It's a bit clumsy, but it's working. Demo times. I have no demo on this laptop, so no demo time. Thank you.
One question.
Yes? Actually, I tested the two implementation. This one is providing me RGB frames in 32 bits.
On Zoom, I'm going to leave it.
And I had one which was providing me I can't remember. It's 565, yes.
Did you finish Zelda with that?
Sorry?
Did you finish Zelda?
I was able to start with Zelda.
Good. Thank you very much. Shit. Oops. Sorry, I'm lost. Niklas, are you around? God, I hate this Windows thing. You have 10 minutes.
I only need 5. So, my name is Niklas Haas. I want to talk to you quickly about how I made image downscaling faster and better in libplacebo. So, image resampling, just kidding, signal reconstruction. So, quick primer, I'll try and be brief. Say you have a signal that consists of discrete points like pixels in an image, for example, these black points here. And you want to know what is this continuation of the signal in between those points. Easiest way to think about it, in the context of libplacebo at least, you have this green function, which is known as a window function, or a weight function, sorry, also known as a filter kernel, and it just assigns weights to each distance. So you place this function at the point you want to know the sample value of, and then it's very simple from there on. All you have to do is multiply this weight function by this pixel value, this weight function by this pixel value, this weight value by this pixel value, and so on. Add them all up, and hey presto, you have your reconstructed signal. So what do we need to do to implement this on the GPU? Well, it's very simple, right? We just need two things, the weight values, and the image pixel values. So let's talk about the weight values quickly. This is actually the easiest part. First of all, the weight functions, well, they're not so easy. They're actually quite non-trivial to compute because they involve, awful things like trigonometric functions, floating point division, and Bessel functions. So what we do is we just cache them in a lookup table, and because this is a GPU, of course, we only have floating points because integers don't exist. So our lookup table is just indexed by a floating point value, which is the offset that we have here. So for example, this would be 0, this would be 1, and every position in between gets its own offset. You look up this offset in the lookup table, and you have your 4 weights. That's done. Okay, done. So next thing we need, well, we need the image data, right? So easiest thing to do, okay, we just load each pixel from the source texture, but that works. I mean, it's fine. That's what we did for maybe 10 years, and it worked fine. So, but how can we do better? Well, first of all, the problem here is that we need 1 texture read per image pixel, and that is a problem because texture reads are slow. Well, I mean, they're fast, but if you do millions of them per frame, then they're slow. So we want to try and minimize the number of texture reads we need as much as possible, because actually the GPU limits you on the number of texture reads you can do per second, and that's usually the bottleneck when you're talking about image resampling. So to do this, we have a new trick, which is actually an old trick. I just rediscovered it. And turns out GPUs are very good at linear interpolation. So if you ask a GPU, for example, give me the pixel value at this position in the image, even though the pixel doesn't exist there, it will just linearly interpolate the 2 surrounding pixels. So effectively, you get, with 1 texture read, you can effectively read from 2 source pixels at the same time. Of course, only within the constraints of this linear interpolation, which turns out is mathematically easy to express like this. But what we actually want is this, because we want these two weights which we have from the filter kernel. But fortunately, some simple algebra can transform these two expressions into the same thing. I won't go over the details. And the good thing here is actually, if you'll notice, we only need two numbers, really. We need the offset, and we need the combined weight. And so the actual lookup table size hasn't increased, because instead of storing W0 and W1, we just store this number, and hey presto, we just improve the efficiency of the lookup table for free. Big problem is, this only works because of the way the mathematics is formulated if the sign of the two weights are identical, which in practice means they both have to be positive, which is a problem because our default the filter we use for resampling by default has negative weights, like most good filters. So I searched low and wide, and I found this function, which is pretty good. It has three main advantages. First of all, it has a very small support, which means you need to look at fewer input pixels overall. Second of all, it's entirely positive, which means we can apply this linear resampling trick. Third of all, it's extremely easy to compute. In fact, so easy that in many cases we don't even need the lookup table because it's just a GPU built-in intrinsic. So that's what we do now in Le Placebo by default. Here are some pointless quality metrics. Here's the performance speed up, and that's unfortunately all the time I had planned for this talk. So I wanted to talk about a lot more, but if you care about anything related to, upsampling, downsampling on GPU, compute shaders, whatever the other tricks we use, anti-ringing, then please ask me. That's everything. One question?
Because he was so fast, you're allowed questions. I have a first question. You're showing quality metrics, yes, but you did not define a new quality metrics. This is not professional.
I have a question about that last polynomial. That means you change completely the interpolation you're trying to do, right?
You mean the results? Well, yeah, it changes the visual results, and it's easy to distinguish between the two. But actually, in terms of both quality metrics and subjective evaluation,
can you hear me? Can you hear me?
On this, it turns out this function actually looks slightly better. So while it is a different result, yes, in this case it doesn't really matter because all functions look sort of good. When all you're doing is downsampling, it's much easier than upsampling because you're just throwing data away conceptually.
It's on my side now.
All of these functions work quite well in practice. So we just pick the one that has the best mathematical properties.
Can you hear me now? Hello, hello.
Meaning you're not done.
I'll expect a bigger talk next time, hopefully.
Running tool.
Good. Okay, thank you.
I can't hear you. Are we talking or? Can you talk?
So the next lightning talk.
Can you hear me?
Is
no, yes, no. Can you hear me, Paul? Oh, now there's pictures but no sound.
Supposedly that's supposed to be me.
Oh yeah.
Results.
Oh yes. Okay. Can you hear me?
So, those are the results.
Can you hear me?
We have two teams which are tied to the first place, right? There is Team 8 who has no name. Next year, if you have no name, you don't get points, right? So I should have precised that. And we have the Kyle team, which is Kyle and so on, but it's going to be called the Kyle team.
Hello.
Weirdly, those two teams, which have almost all the good questions, can't do the most simple ones, which is one cannot do a simple addition, and the other cannot count.
Yes,
up to
don't
5.
touch anything.
It's really amazing, but still they got the best results. Weirdly, the other, which has Lepome and Group 3, okay, another group with no name,
so I think you'll be next.
Are very,
but they need to fix the sound in the room.
Close. So how do we do that? After long discussion, this is a coolest picture of everything. Some people, and that means one group, actually went into the museum, and I guess you're the only one, so congratulations. Actually, the whole work of Kyle photos could be a presentation on its own. It's really, really amazing. But the best picture, the artistic one, is actually this one. But then you have the whole group. And if you take the whole group of pictures, well, there is one guy who did a fuck ton of really cool pictures. And again, this is François, And like for weird reason, François also managed to talk to this guy who is a weird person somewhere, who played in Plus belle la vie for the French people, and who is actually the guy running the pharmacy. So how do I decide who won? And of course, I did not at all cheat on the questions. Yes, the correct, only one team got the right answer, which was Coca-Cola, and that's one of the late team. Yes, it was normal. There is no fish, right? There was 0 fish, and 13 on the other part. What was the other horrible question? I don't know, all of them. It was on purpose that they were difficult. Also, some people have taken the wrong church. I don't know how you did that. So, in order to know who won, well, you've done an escape game, right? So we took the people who were the fastest. So Team 8 was faster than Team Kyle, so Team 8 wins. So, yes. That was also why you had like a competition of race. There will be an extra, just for Kyle, for your photos, you will have an extra thing. And of course, who won the escape game? Well, the organizers, right? So, Team Vibhuti, Julien, Sébastien, and me, we were like torn faster.
Yes.
Okay.
Thank you very much.
Just wrapping up now, can you hear? It'll be close.
Why is it cheating? Yes, yes, that's true. Thank you. Now we are going to have François, who's doing a lightning talk.
No?
Huh?
No, GB will... Oh.
No, Paul is ready? Okay, no, so we're doing Paul.
So GB is going to mix you into the other...
How many steps were there?
So we're good.
Okay, so we have a question. I think the correct answer was 14.
So you should be able to join the Jitsi.
Blah, blah, blah. Yeah, was not Warble and Ren. Which one did we win? Yeah, 14 was the correct answer. And the correct answer for the letters was SIVM. Yes.
Where's Vibhuti? Vibhuti? I think you need to turn the house mic up.
And
I think house mic is...
And the correct answer for the quarter turns, the only team who did the correct answer was this one, but which is group 3, which says it's actually 6 quarter turn or 62 quarter turn, depending on how you count. Anyway, congratulations for the people who won. Let's play next year. And I promise you, next year it's going to be a ton more difficult because this was too easy this time.
So unmute and then start talking, Paul. And then we need to check the sound levels.
Is Jitsi so laggy?
I can hear you.
I can hear you and I can hear Paul.
You can't hear me.
You can't hear me. You need to boost the sound.
Yes, I can hear everything.
Yeah, but we can't hear you.
Yeah, but we can't hear you.
Do you hear me?
I can, but the audience can't hear you.
I can, but the audience can't hear you.
Ah, it is coming now. Why is this so shit? Ah, okay.
Yeah, that's already 100, so it needs manual boost. Could be. Oh, he's left. Paul, you can go.
Ah, just a moment. Ah, it should be fine now.
Oh, wait, 1 sec. We need to rejoin the conference. Yeah, join.
And turning off video.
Yeah.
Can you hear us now?
Paul?
Yes?
If you go.
There you go.
So, can I start my presentation?
Well, no,
Hello. So I will start presentations about reverse engineering the coders of popular or dead codecs about FMPG. So let's start. Uh, there are many ways to reverse some codec, so I will just some perspective that I attempt in my attempts to reverse various codecs in my work on for FMPG. So FMPG. So I first step in searching for codecs from is to search web for basically to scrap or available resources on web about some codecs. And there can be some other people that already did some basic work or anything related to codec. And next thing, maybe you can find some formats, information about containers and etc. that is already done, and usually it's possible only to find for proprietary codecs only some white paper to represent some information generic about codec, and then you basically on your own. So because of all of this, you need to first, if you can't know anything about codec, you need to research it. So you just need to know about everything codecs you can find in binary by disassembling this and start all that stuff. And first step is to get samples, because without samples you can't do anything to write the code. You can test and everything, all that. And best thing in that case is using reference encoder if you have one. If you don't, you are on mercy of samples you find on web or some other people that can provide you samples for the coder. Then important step is prepare an environment for development and research of the coder you want to work on. So there are many tools you can work on to use to work on this, the coder research for reverse engineering. There are many tools, various functionality and bugs in these tools. Every software has bugs. So this is starting from disassembles, hex viewers, editors, debuggers, the compilers, data visualizers, and pattern scanners. It can speed up the development and research process. And then you are on your own to begin actual reversing work. So you first is to get a frame of audio or video packet from unsupported codec or format. This is simple command that is still working, and that is can give you from container some first frame you can start working on. Then you can start to explore bitstream by binary by using hex viewers or the editors like Radare. It's typical what I use to explore hex binary, and this assembles itself, and you basically search for patterns inside same binary decoder and also in some binary or bitstream file. So after you just explore everything you can, and you can't explore something if you don't know some basic information about coding and etc. This is a very vast space of information that you need to work on something, and this is extra points for additional skills. So you need assembly language knowledge, instructions for architecture that is binary of the coder in based from, and then you need to know anything about algorithms used in same codecs, and then you need to know also FMPG, libcodec, libflow internal code, because if you are going to write the coder for it. And if you're stuck, you just need to look at this problem of reverse engineering from different perspective. And to success in writing the coder, you need persistence and multiple attempts and not stop at the first failure. Once you do all the work that is really complex, and for this short time to represent any demo or example, don't have time. So just do the book session and iterate from start to finish. And once you write basic implementation of first draft version of the coder, you send it for review. And once you get review on list, you fix everything's mistakes you've done and get it merged in the codec, and also write tests later on, and you are basically finished. But there is one single thing that you need to also provide some samples. Otherwise, as code by ways of project changes during time, you need to have coverage of the coding as far as possible to reduce regressions in the coding functionality for that format container codecs in much less possible case. So that is not, so doesn't any problems arise because some maintainer changed something in your decoder or other people's codecs, and then it breaks some special condition. So it is very problematic. So you need to, if you need to sustain and to have full support all the time, you need full-fledged coverage for everything possible. So I'm basically very against doing changes to decoders that are ad hoc. So that's all for this presentation from me for now. Is there any some comments or questions?
Which buttons can one at a time, yeah. How many formats are still not supported?
So Nathan asks, how many formats are not supported?
Well, for formats, there are many formats on build that are not supported, from various game formats to some proprietary internal formats. Same thing for codecs, for the coders and coders. But I just concentrated on the coders and less on containers. They are a little simple to implement, but they are not encrypted. So that is for containers. Actually, you write the maxer for containers. So this is mainly about codecs because they are more complex to do. But there are many in the build, but we intend to implement only the most popular or most available on case by case basis, but most available samples in the build on the web. Or if someone reports bug report or feature request on track of FMPG site.
Vittorio has a question. What's your favorite decompiler? The question from Vittorio is, what is your favorite decompiler?
I don't have favorite decompiler because everyone has many flaws, and I usually use combinations from every possible there are, but my favorite is none. I mostly use CLI tool from Xterm that is Radar as disassembler, and it's the compilers is GitHub plugins from NSA, secret agency. So it's because it supports those unlike other compilers, but there are other compilers there are also useful in some cases, but that all depends on your scenario and various aspects. Also on the same versions of binary they compile. There are many different versions of the coders because the binary is also changed from time to time. Versions you can find from that binary you want to reverse.
Do we have time for a decompiler demo, Paul?
That is a little complex to set up. How many times do we have? I don't have the compiler here. I just have radar.
People are shaking their heads. So, okay, so we don't have time for a decompiler demo. But any more questions? Ronald has a question.
Once the decoder has actually been written, what techniques does it use to verify the exactness or the correctness compared to the original binary implementation?
So the question from Ronald is, once you've finished writing a decoder, what techniques or methods do you use to verify bit exactness or correctness compared to the original binary implementation?
That is basically only done for lossless codecs, and that is actually mandatory to have bit exact to reference. And for lossy, that is less important. It just needs minimal difference just to be visually same output for lossy codecs, both audio and video.
Any other questions? No? Sorry?
Which pattern scanner?
I don't understand what you're saying, sorry.
Which pattern scanner?
Which pattern scanner, Francois asks.
Which patterns?
Pattern scanner.
A pattern scanner. I just now currently use Beanwalk, but it is not perfect. It is mainly designed for some other cases, for like forensic. But I will also search patterns if I suspect that binary have it with radar and it's hex searching for patterns. It has other nice cases, and I don't knew how to use 99% of features that radar have because it's very complex, and it also have various bugs and miss features, so it's very hard to learn it. So, but basically it have many cases for bit pattern search or assembly bit pattern search, and that's everything about that patterns. But there is other cases, generic pattern search for containers, and that is, I just use what I found, and I didn't make more research about pattern searches. I usually just use file tool to just from some basic first thing grasp if the file is clone or it just have anything useful in it, or it is just pure unknown bunch of bytes. So I use Bindback, that is Python tool.
Any other questions? No? So please thank Paul for giving up his time to...
Thanks.
And I'm sure people can contact you on IRC and email, right, Paul?
Yes, if they want to start this adventure of revising important codecs.
Thank you. Have a nice day.
Thanks. Bye.
Bye. Incredible. Who's next? Do you know where your presentation is?
I don't know.
Which one is it? not that one because I'm not there. This one? No. No. I am the new JB now, so just to let you know. How did you send JB your presentation?
Slack.
Slack.
Where's GB?
Slack. Great.
Where's GB?
I'm not as nice as GB. I will mock you on stage. It's okay.
I don't care.
Slack.
Did he send by mail?
Yeah, but how do I get Slack on here?
No, he probably sent to himself.
Oh my God.
By mail.
Yeah, but I'm not looking at his emails on.
Yeah, so we don't care.
Otherwise I can blank projector blank.
Anyway, it's not important.
No, but okay, I can blank the projector. And how do I do F11? Right, lightning talks. Which one is it?
Me, I think. Probably sent to him.
Evolution?
Yes, exactly. Good.
Okay.
Okay.
How do you make it full screen? 11?
I don't know.
Yeah, and unblank.
Your full screen? No, it's not full, it's full screen.
I mean, it's the best you're going to get. This is Adobe Reader. It's garbage.
Really? Shit.
Where's present? This one? No? Where? Oh, present. Ah, yeah.
Good.
Good? No, good?
No, that's not good.
What?
It's not good.
What?
Qu'est-ce que tu fais? Mais qu'est-ce que tu fais?
C'est Monsieur Abba.
Guys, I know it's Windows, but come on, like, make an effort.
Oh, joli. Okay, guys, really short. I wrote this in 5 minutes. I have this idea in mind for a few days. This is really, what next? Next, how to go next? Wait. Okay, I have a question for everyone. Please don't answer immediately. First, I like monolithic content. Second hint is I have no idea what a B-frame is. I have no idea what also is a subtitle. Maybe, don't say it. Please, no name in the community because it's a format. It's no one here. I'm born in 1992. You get it?
Yes.
It is? AVI. Good. Thank you. I have another question. What is this?
Anything you want.
You're right. This is also an AVI. Why do we have this? Because we have a lot of users who still think they need AVI everywhere. We all run into that case where we receive files and it doesn't match the content and we still have old formats around. Those formats we're dealing with for too long now. And we don't want them anymore, probably, because we don't need them. We don't need them. And recently, well, more than probably 10 years ago, Microsoft also did this with i6. But probably we don't want to do this. We don't want to make it disappear. So denying access to and producing new AVI content probably not a good idea. But can we do better, like warn in an aggressive manner? Like, you are doing something really stupid? No, maybe not. Or have really standard strict option like FFmpeg does? Maybe not. Can we also politely ask people not to produce that content, only if they need it? Maybe. But if we do this, can we do something smart, like a profile option in the players and maybe a break or something? Like enabling or disabling AVI? Yeah, maybe not the best idea, because we also have a lot of other technology associated. So maybe we just want a set, or maybe we can also be smarter, just offer the user to enable technology by their age. Okay? Because user can understand that it's enabling something which is pre-2000K, pre-2K, 2000? Yeah. Yeah, so we can think about something in the UI and, okay. So that was just an idea. That's all. And maybe we can pull the plug of a few of them. Okay. Thank you very much.
François, what have you been drinking yesterday?
He speaks the truth. IBI must die.
No, I don't have it. No. No, where is it?
The USB memory, right?
I love the fact that the only USB key we have is something bootable with EFI. Give me. Oops. No, don't save.
And you have my total was save games.
What is that? Typic shadow lesion. Can you play that inside VLC or not? Okay, so probably our last talk for today. Takesato, thank you.
Hi. So, I think many of you who is this guy, and I know some faces familiar, but maybe you didn't know me, so the answer is these three. I was head of host country, VDD 2019 Tokyo. Thank you. And the organizer of Tokyo Videotech, and three, customer engineer at NPAL. So, and here's my teammate who supported Video Dev Days Tokyo, and you know, it's amazingly every single person and very happy to host you guys in Tokyo, and they say they want to do something in the future. If there's chance, we would like to host BDD in Tokyo again. So. Then, and here's a couple of hot photos, and maybe you see some faces.
Most of the people in the sunlight are with them.
Yeah. Okay, and the good news is that all the photo download is still available, and if you take a photo here, and you can download right now from Google Drive, and I will send these URL for the signals later. Then I would like to talk a little bit about Tokyo Videotech. So what is Tokyo Videotech and meetup group for anyone who is interested in online video technologies, and mainly for engineers and technology side of stuff. And we started Tokyo Videotech in 2018 and December 2. And organizer and the sponsor is Ahil Networks and Spurs. And we have 279 members and part of the worldwide video engineer community, including San Francisco Video Technology and London and Paris and around the globe. So, and we have, meetup page, something like this, and you guys are free to join. And we are avoiding, spam entry for our group. So we have to permission at first, but after that, you can, enjoy Tokyo Videotheque. And also, we have, Medium, page and written in Japanese and English, so and you can take a look. So, and feel free to ask me anytime. And if you want to, speak at Tokyo Videotheque. And unfortunately, and after 2019, and we suffered in COVID, and we are not able to physical event at from them, but we did, 2 online events, and this year we will start again to having a physical event. And if you guys want to, have a little bit talk or lightning talk, please and ask me, and or if you just want to drink with me or our teammate, and that will be welcome, and also otaku talk together. So. This is my email address, and if you okay, and please email me anytime. Thank you.
Okay, did I promise anyone that he had a talk and I've not make him speak today? 1, 2, 3, we are dead. Okay, so this is probably the conclusion for VDD 2023, for the talks at least. We have 1 hour for food, and then for the people who are part of the Videoland nonprofit, you need to go upstairs in the room 3074, the big one from yesterday, not the small one. It's important. I would like to thank everyone for the organization. Thank you, Anil. Thank you, John. Thank you, Vibhuti, of course, because this is probably the VDD that we organize in the least time. You know me, I've always done things à l'arrache, like really just in time, but this was even more just in time than usual. Yes, Kyle?
How many questions was he responsible for writing?
What?
How many questions was he responsible for writing for the trivia?
As many as you want.
How many people did end up attending VDD?
This week?
Yes.
I counted 82 at max. Basically, the thing is, like, as you've seen, I've not announced VDD to any non-geeky mailing list this year, because, like, when I opened, we were 60 already, and so that's how it came to, like. I did not submit it even on Twitter or Facebook or LinkedIn and so on, right? The thing is, I like the fact that it's a very technical conference. Like when you see that DMUX is considered technical by the industry, right? We are a bit more nerdy, and it's weird, but we like weird. And also, we are not a university talk, right? Some of the talks are closer to university talks, but we are like really in the middle, right? So that's cool. I really enjoyed that. I really hope that you enjoyed the Dracula patent troll fight. Of course, it was the usual. We'll try to make it more difficult next year, to be honest, because like this one was too easy. We had like too many people who are tied. Which brings to a good question, is that where do we go next year? If you have a good idea, please submit that. They're like, because we've done it in Europe, we can do it in Asia next year. The usual countries are forbidden: no China, no US, no Middle East, no South America. Okay?
Why no South America?
Too violent. Too violent.
Well, we just don't invite FFmpeg.
Okay. I hope you enjoy your VDD. Some people are going to leave during the afternoon, but we can stay here until 6 p.m. We have the same room as yesterday, so we'll have the ASSO meeting at 1:15, so for 1 hour and something, and then we can talk about anything else. If you have any question, any complaint, please ask me. I will consider to ignore any complaints because, well, you've not paid. Thank you, everyone, for coming, and thank you. Food is ready. Bah oui, c'était la bonne église. Attends, vas-y, là, on va aller discuter, Comment ça, t'es pas là pour gagner? Évidemment que t'es là pour gagner. Tac. Yes.
J'ai une question vis-à-vis du meeting. Est-ce que est-ce que je peux le manquer?
Non.
Non, j'ai pas le droit?
Non.
Est-ce que tu es membre de l'association? Bah oui, je suis membre de l'association.
Et bah donc non.
J'ai une opportunité d'aller
non.
randonner sur les...
non. À 2 heures, on a fini. On a juste l'élection à faire. Dans 1h30, tu peux être parti. Tous les papiers ont déjà été découpés. Les papiers sont prêts, ont déjà tous été découpés. Hein? Yes, that's me. I'm not sure I'm that glorious, but the fact... Yes, so we need to discuss during lunch. But first, let me save all this shit, if I can. What laptop you want?